Hi, my name is Mohammed Hamza and I am one of the experts at AxeUSCE. I'm currently a chief resident at Mercy Catholic Medical Center and I finished my residency at Albany Medical Center. My med school was King Edward Medical University. Okay, so we were going to start with the mevacamptin data that Hamza Naveed has just recently collected. And when you guys give me the data, the first thing that I do with the data is I have to clean it so that I can load it into the software. And once I clean it, I can load it into the software. And once I load it in the software, I can run some number, I can do number crunching on the data. Okay, so let me share my screen. So this, okay, let me just first share the screen here. This screen. Okay, you guys should be able to see my screen now. Okay.
Yes, we can.
So the first
Yeah, we
thing, for
can.
example, Hamza gave me this data. Let me just open up. Hamza gave me this data. Yeah. So this is the data that Hamza gave me, right? So this is the baseline characteristics. So when we do a meta-analysis, baseline characteristics, we just have to report as it is. Normally, once we clean it up, we're gonna make it prettier so that we can send it to the journal. Then the next thing that we do run the analysis on is the outcomes. An outcome is the one that we actually do the run the analysis on. And Hamza, adverse events, I'm not sure. This is n and percentage. I'm not sure this is the one we're gonna run analysis on. If I'm right, am I right, Hamza Naveed?
He's muted. He's
Oh yeah,
muted.
yeah, yeah. I was gonna actually. Sorry, I was muted. Yeah, we're not gonna do the analysis on
Yeah.
the adverse events. I think it would be like too atypical to do that. But it was the most common findings in terms of adverse event in all the three trials. So I just want to like
Mhm.
report it just in case if we
We
try
can
to.
actually we can
Yeah,
actually make a table of that the adverse events. Sometimes adverse events, if they are significant like syncope. So syncope is an adverse event. I would like to run analysis on this one as well. But this is n percentage, so I actually needed n and events to run analysis on. And I don't think so. It's you mean here. You mean n and percentage here. If I'm not right. If I'm
yeah,
right.
yeah. I wanted SD, and the one other outcome, like adverse event, was a sudden cardiac death. Because whenever, even in like during the step preparation, like a sudden cardiac death and hookam kind of go
Mhm.
with that. So I just want to like report these kind of
Yeah.
bradycardia and even septal ablation. These are the most common complications that any intervention had, like the surgical intervention.
Mhm.
That's why I want to like report like mavacamten is better than the surgical
Mhm.
treatment that are available.
So actually, those would actually come in the outcomes then, because the adverse
Okay.
events are also outcomes, so that they would come in the outcomes.
Okay.
So the thing is, because here they are not in n percentage, so once you give me in n and events, we can actually run
Mhm.
outcome analysis on that. But the thing is, if they are 0, 0, 0, then nobody's going to run analysis on this. 0, 0
Yeah.
software doesn't read it. So then we have to drop these outcomes. We can only do outcomes like significant outcomes. I think syncope, this is a significant outcome, but last study did not report it. So maybe we can do analysis on this one. Then maybe AFib is a one, but I don't know how significant is that. And this is the AFib one. BTAC one, we can run analysis on this one. Bradycardia, this is reported by one study. So anything that is reported by just one study, we cannot run analysis on it. Okay. So
Mhm.
this is the study actually that you gave me. This was the analysis. So if you see this paper, first, I cannot, when when I run the data into a software, I cannot have three different columns, three different rows talking about what's going on in this column. So I have to add it in one row. So let me share you another screen to tell you what I did.
Mhm.
So this is what I actually did with this one. So first of all, add a serial number column, then study, then whatever is the studies, it all clean it up. Then I SRT evaluation, you said this one, right? So SRT eligibility
Mhm.
events in Meva. So that's what I
Mhm.
did. SRT.events.meva, then SRT.end.meva. Okay, the same. The next thing you said in your data was PVO2 mean ST, mean ST. What I did was I changed it into this. So VO2 mean MEVA, ST MEVA, mean placebo. So that way I have everything that you have written over three columns. It's good to write when you are doing data collection, because then it's easier to data collection, because it's difficult for a person who is doing data collection to read, to understand what we mean by VO2.ST.placebo. So, but when we are doing the analysis, we have to clean the list up so that we can upload it. And then I did that for all the outcomes. The other thing is that you see most of the outcomes here have at least two studies, two outcomes. But here, when you are giving me, some of the studies have actually just one. For example, this just one, and this does not have any, ST as well. So what I did was I dropped these because you cannot run a meta-analysis on just one, on an outcome that is reported by only one study. So I have to drop these. So I cleaned the list up, and now this is the list. Now for R, whenever you have to report something in R, it should be in CSV. So what I do is I always save my file in a CSV pattern. So when you save a file, let me see. So let me say save as. So you go save as. You have to do in comma delimited CSV, or only read CSV. Stata can read Excel file dot XLS, but R can only read .csv file. So I did that as CSV, and that's the file I created. Okay. Now, when you have R, so when you open up R, so I was actually doing the analysis. So you see these four things. Have you opened up R in your computer app before?
It's
We
been a while
downloaded
since
the
I
R,
used it.
I'm sorry.
we downloaded the R and opened it up, but I
Okay. Did
didn't.
you download the R Studio?
Yeah, R Studio as well.
Okay. Open up the R Studio. Don't open the R. Open up R Studio.
Okay.
So when you open up R Studio, let me see R Studio.
Mm-hmm.
So whenever you open R Studio, you just give it some time to load. So it opens up these four, actually R script. So these four windows. So this is actually your output window. This is actually the window where R shows all the variables and all the outputs and everything. And this is a help window. Okay. So whenever I start to run R, so first of all, what you have to do is for meta, I'm not going to go into very little details of how to add vectors or how to add variables in R. I'm just going to show this thing. So whenever you have to create a variable, you do this. Let's say I'd say um, lecture is a variable. I want to add a value in this variable. I want to assign something to this variable. I can say, so this is the symbol in R, this one. This sign and this sign, which shows that I am assigning this something to this variable. So this is the variable I'm assigning something to this. So I will say, let's say I'm assigning number 9. So I run it. Lecture is a variable now with number 9. Okay. Then I say I'm gonna add today. This is a new variable. I'm gonna assign a new number to it. Let's say 10, and I say so today is 10. If I say lecture plus today, I run this command, it's 19. Okay, so this is where I assign the variables. This is how you assign the variables. Okay. Um, in R, you can assign a single number to a variable. You can assign a series of numbers to a variable, or you can assign a whole data sheet to a variable. You can do anything in that. So right now, this is just to tell you the basics. Now, before we start doing meta-analysis, so R is actually composed of packages, statistical packages. You install a package, that package does its job. That package can actually make maps for you. That package can actually do meta-analysis for you. That package actually can do all these different things for you. But you have to load a specific package. Like this, in this sense, in front of you, R cannot run a meta-analysis. So you have to install packages for meta-analysis. So the command for that is install dot packages and then meta. This is a command for installing packages in R. I have already installed it in my computer, and when you install it, it already saves in a certain part of the computer. Okay, it's already installed in my computer, so I'm not going to go in that. But let me go to this file. So I installed R packages here in Meta. Once you install a package in Meta in R, you have to load a package. So how to load a package? You do this command library Meta. This is the command that you actually give to R to load that package. Can you see my screen clearly?
Yes, we can.
Yeah. So I run this and R plus enter. So this has actually already, the package is already loaded. So this package is loaded now. Now I have installed the meta package. I have up the package meta package is now loaded into R. Now I have to start my analysis. Now this is the file that I created, right? Initially, I have to load this package, load this file into R. Now, how am I going to load this file into R? I'm going to make a new variable, meva. This is a new variable, assign it what? This is the command read.csv and then open bracket, then file.choose. Okay, so what I'm actually doing is I'm actually doing this. So if I just do read.csv, it's going to ask me where is the CSV. So I open it up. So this is how you give command to R. Now I'm saying, okay, I'm giving a command within a command. So file.choose is a command within a command. And I'm gonna do this. This will open up a dialog box. So this dialog box is actually opened behind. I can I don't know how I can. So this is the dialog box now. So I'm gonna if I click on this and I open it. So this is the whole data which is in the file. Any question?
Yes.
But right now I have not assigned it to a variable. So this is just read.csv. This data is just loaded. It's not assigned to a variable. But
Yes.
if I'm going to do this, if I assign it to a variable meva, and I'm going to use this. This is the variable, assign what to it, whatever is in the CSV, assign to the variable.
Okay, so you just, for the purposes of coding, you defined Miva to be whatever was contained in this CSV file.
In the whole CSV file. Meva
Yeah.
would be a variable which contains the whole data.
Got
Okay.
it. Yep.
Now I'm gonna load it. So I loaded it. Actually, this is opening up behind. So I'm actually gonna make it come to the front. So this is the file. I'm gonna open it, and this is now gonna be in the Meva variable. Now I'm gonna see the variable if is it right or not. So I'm gonna use this view command, and this is the file. Serial number, study, SRT, everything that we cleaned up.
You're just confirming that when it loaded into Miva as a variable, that it retained its structure.
Exactly, it retained its structure. So now it retained its structure. Now I know that that whatever data that I had is actually loaded into R. Now, next thing what I have to do is I have to start meta-analysis. So now we installed a package, we uploaded the package, we uploaded the data into R and assigned it to a variable. Now, this variable is actually all the data is in this variable, right? Now what I'm going to do is I'm going to run the analysis. So there are three multiple different types of analysis that you can run in R. So if you want to see how I can do meta. This is a command which shows you question mark meta, which you can actually see what exactly is this meta package, how you can run the analysis, how you have to give the commands. R can actually teach you along the way. So I open it. So this is the whole R package, meta package. This is how it's going to help you. It has meta regression, it has cumulative meta analysis, it has all different types of things. It can have Labe plot, forest plot, funnel, Galbraith, Bajart plot. I use this Bajart plot a lot. Bubble plots can be do for meta regression. I actually do meta regression on Stata because the bubble plots are actually much more beautiful on Stata than R. So these are the basic meta commands. So meta, if you want to run a meta analysis of continuous data, continuous variable, you use meta cont. If you use binary data, then you use meta bin. If you do just incident rates, meta inc. If you just generic variance data, then meta gen. If you do this meta of single means, if you have, let's say, you have a series of means and you want to find a pooled mean, you do meta mean. If you have single proportion, then you do meta prop. So these are all the things you can do. But most of the time, what I end up using this meta bin and meta cont. Okay. So now so take a look at this. So SRT eligibility is actually a binary variable, right? It has events total. It's a binary variable. You guys agree?
Yeah.
So it's a binary variable. So we have to run meta bin on this. So I actually create a new variable, meta SRT, which will denote the type of which beta analysis I'm doing. So meta SRT assigning variable, then start meta bin. So what is MetaBin? I can open up this one and this will tell me what is the exact coding of MetaBin. So this says event.e. What are the events in the experimental group? Which variable denotes the events in the experimental group? So here, the events in the experimental group is Meva, events is events, SRT. So SRT.e.meva is the events in the experimental group.
Hold up, Hamza. How did
Yep.
you pull up? How did you pull up the coding within the parentheses?
Okay.
When you,
Yep. I'm
did
gonna.
you just put it? Right.
So this is question mark meta. This will tell you everything within the meta package. You run this, this will open up. You click on this,
Yep.
and this will open up. Or another thing you can do is instead of just doing question mark meta, you do this question mark meta bin. You run this, it will open up meta bin coding. If you want to do meta continuous question mark meta cont, this will open up meta continuous coding.
Got it. So when you put in meta cont, it put all that next line of information, meta SRT.
No. This is different. This is different. This is different.
Okay, yeah, I'm just trying to see where you pulled that from. Did you already have that as a template? Did you control
No.
C and
Okay.
it?
I will actually develop this in front of you. So
Oh, thank you.
let's just do this. Let's just do this. So meta bin. I have opened meta bin coding here.
Yeah.
Okay. Now I need to start meta analysis. So I'd say meta SRT. I'm doing meta analysis for SRT eligibility. This is a new variable which will have the meta analysis data. Assigning sign. Then I'm going to run a meta bin. Okay. Then I'm going to say this meta bin coding. I'm going to run this code here. Okay. So here is events.e. Events.e means events in the experimental group. So R will actually help you out here. Event.e. So which variable in this table has events in the experimental group?
Millen seems to, as well as Olivo, everything basically except for Carolyn.
I'm sorry, can you go again?
So it seems two studies do, as long as it's not Carolyn.
Yeah, it's not Carolyn, but I'm saying which variable? What's the name of the variable that has events in the experimental group?
SRT.E.MEVA.
Exactly. So I'm going to write events.e is in srt.e.meva. Okay, comma, next line. Next line of coding is NE. NE means number of events in the experimental group.
Total events.
Total. And what variable is n.e?
It's like very small. It will be the event.n.meva.
It would be srt.n.meva.
Yeah.
srt.n.meva. So I'm going to write here srt.n.meva. Okay. Then I need events in the control group. Okay. So I'm going to say events dot event dot c. Which variable has events in the control group? This one, right? srt.event.placebo. So srt.event.placebo. Then I have total in control. So I would say n.c is which variable is this? srt.n.placebo. That's why whenever I'm asking you to guys make a data sheet, I'm asking you to make 4 columns of a binary variable because it helps to upload it into the data sheet in the software. So we're gonna see srt dot events dot n dot placebo. Okay, now the data is loaded. All the variables are loaded. Now I have to tell R what kind of analysis I want it to run. I want it to run. So the next thing I have to say study label. So which of these columns has the label of the study? Which of these variables?
So it's studying the variable. Yeah.
Exactly, the study variable. So I'm just going to write study. Now data. The next is data. I have to tell R which data I want it to grab. Where are the variables located? So what is the variable of the data?
It's in the multiple rows, row 1 and 2, I think, if I'm remembering. I
No,
can't recall.
the data variable, the
Meva.
variable that contains
Oh,
data
Meva.
is Meva.
Meva, yeah, you can find
Yep.
it earlier.
So
The
I
whole
said
file is.
Meva. Now the data is uploaded. Now I have to tell it what kind of method I wanted to do. So in binary meta-analysis, the most common method that we use all the time is mental Hensel method.
Mm.
Okay. So what I have to tell R is MH. So if you go down, this will tell you what kind of methods are there. And if you need to know more details about it, you go down and it will tell you the method. So it will inverse method, there is Peto method, there is GLAM, SSW, but the most important is the MH, mental Hensel. Okay, so it notified mental Hensel here, comma. The next is summary measures. Summary measures is RR, OR. So all of these are trials, right?
Mm-hmm.
The
Yeah,
summary
in
measure should
RCTs.
be RR, risk ratio. Then I have to tell it, do I want to do random or fixed mode of analysis? So all the time in biomedical sciences, we use random mode. We never use fixed mode of analysis. So I have to say random is true. Okay. There is one more variable that we add, which is the incur variable. Incur variable, what it does is, let's say if you have a value which has 0 in it, no events, that value will be excluded by the software. In order to include that in the analysis, what the software does is we use a variable called incur. What incur does is incur gives the value, incur gives the certain event a number, let's say 0.5, to run the analysis, and once the analysis is done, it takes the number back, so that in the end the value or the study is included, but it does not affect the results. So I'm going to add incur variable, and normally the value of incur should not be more than 0.5. So 0.5 is the incur that we add. So that is the, so this is our whole coding for the meta analysis. So we run it. So this meta analysis is now run, and this is now in the new variable meta SRT. Okay. Now what I'm going to do, I'm going to see what exactly did I do in meta SRT. I'm going to just write it and I'm going to see what is going on. So this is what's going on. So total number of studies in the analysis was 2, because only 2 studies reported on the outcomes. Number of observation was 319. Total observation, if you add them all together, it comes out to be 319. Then number of events, 163. Common effects model. So this is what I give you in the text file. When I give you the text file, this is what I give you. So I would just
Mm-hmm.
copy this. I would copy this. I would open up a text file, just a notepad, and I would, this is the previous one. I would just add it. I would say
SRT.
SRT eligibility. And then at the end, what I will do is, I'll show you one more thing that I do, but I don't think so this study will need it. So this is what I do. So I save it. Where do I save it? I save it in the same column where actually this is not bleeding. Notepad. SRT eligibility, file save. So I go to the same file where I have the initial one, remember Campton. I just say SRT eligibility, text document, I save it. So now it's saved. Now I will give you the file. This file will tell you common effects model is this one, but you need to use the random effects model. The RR is 0.2, which means the SRT eligibility for patients who were using Campton was actually low. And this was
Mm-hmm.
significant because the p-value is less than 0.0001.
Doesn't.
Okay. Now I have to make a forest plot, right? So how to make a
Mm-hmm.
forest plot? The command for making forest plot is forest. Then which meta-analysis I'm going to do make a forest plot of? The meta-analysis variable was this one, right? Meta SRT.
Meta
Yes,
SRT.
meta RCT.
Okay, so I just put meta SRT here. Now I have to tell R what I have to do. Okay, let me just show you. So this is the meta SRT. I will open it up and it will create, sorry. This is the forest plot now. Doesn't look very good, right? The reason it's not looking very good is because I have to first, you know, let's save an image. I have to adjust its height and width. So I would say height is, let's say height is actually good. Maybe 400 would be, height 400 would be good. Width, but it needs it's a bigger width. So let's say 800. I update preview, so it's still not high. Let me just, okay. Now this is the good. So this is the meta, this is the forest plot. Zero heterogeneity, p-value of heterogeneity is non-significant, so there is no heterogeneity. That's something else. But this doesn't tell you what is experimental, what is control, which side is favoring which side. Doesn't tell you. So experimental was what? I have to say
Meva.
label dot e, label dot experimental is
Meva.
Meva Campton.
Campton.
So first of all, we have to know the exact spelling of Meva Campton. I always get it wrong. So
Yeah, me too. It's,
so it's
it's like,
Meva Campton. It's Meva
yeah,
Campton.
Campton.
Okay. So let's see it's Meva Campton. Okay. So this is label.e. Label.c is what? Placebo.
Mhm. Yep.
Okay. Now you see Meva Campton and placebo are labeled as E and control.
Yep. It
Yep.
changed.
Now the other thing I have to, this is what I have to ask you, Hamza. So SRT eligibility is a good outcome or a bad outcome?
Um, is a bad outcome, after, especially for the patient who's on drug.
So if it's a bad outcome, then
Hmm.
if it's less in Meva Campton, then Meva Campton is actually improving the outcomes.
Yeah, like for Meva
But
patient,
that's
it
what
should
I,
be less.
yeah, but that's why I want you to take a look at, because this is important. This is where our knowledge comes in. Label dot e, label dot right is what you have to label the right side of the column. So right side is favors placebo, right? This is what you're saying to me.
Hmm.
Just make
Yeah,
sure about it. Then label dot left is favors.
favors Meva.
We don't have to write Meva. We have to write the full outcome, Meva Campton,
Oh.
because this is what we'll, this is the picture that we'll have to add it into our paper. This is the
Mhm.
word. So this should be good and clean. Now let's run this. So you see what's it showing? Let me just save it as an image. So Meva Campton 10, placebo 43. So it tells you, right? So less
Mhm.
patients in Meva Campton had SRT eligibility.
Eligibility.
So it's significant. It's coming to this side. Now
Mhm.
this side favors Meva Campton, this side favors placebo.
Mm.
Okay. Now let's suppose I can tell you one more thing here. This is coming to the very right of the study, I mean, very right.
Okay.
So I want it to be in a certain way that, you know, I want it to be
Doesn't
within the
look too
picture,
biased.
within the
You want to
picture.
recalibrate the line.
Recalibrate the plot. So what I'll do is
Mm.
that I will actually tell it what is the limit of C. So initially here 0.2 to 5. I'm gonna say let's make it 0.5 to 5. Actually, okay, sorry. The argument should be actually xlim. Xlim is the argument, which tells the limitation of the x-axis. So you see it's 0.5, 1, 2, 3. Now it's completely out. I don't know what happened. So I think this is not good. So let's say, yeah, because it should be minus 0.5, not 0.5. Okay, this is something else. Just do minus 5 to 5. It's going all the way.
I think you're missing an argument.
No, I don't think so. I'm missing an argument, because if I was missing an argument, then
Or is there just because of the double bracket or something? Double round bracket?
No,
Or
not
no?
for double bracket, because
You don't think it's a syntax? You don't think it's a syntax?
I don't think it's a syntax, because it should be, let's say if I do 0, um, say if I do 0, then it will only add 0 on one side. See,
Oh.
0 on one side, there is no X scale. So
Yeah. So you just need to what before you self-specify that, do you remember where the numbers were? I
yeah,
wonder
I
if
can tell. Yeah, I can tell you the numbers. So if I self-specify it, let me do this. So this, I just run this. So these were the numbers, 0.2. Oh, so here's the problem, because it was
0.5.
0.2, it was never minus 0.2.
Yeah.
So if I do this, don't forget the commas at the end, guys. Let's say if I do, instead of 0.2, I say 0.1. Let's see how it comes. Yeah, so now it's a little bit inside, but it doesn't look good. I think the previous one was better.
You can always change so it's your right limit that I think is throwing you
Yeah.
off.
Yeah, so I can always change this limit. I think this is the best one. So if I just
The
do
point two.
this, I think this is the better one from all intensive purposes. So I just need to export it, save as image, adjust its width and height. It is important, because if you don't adjust the width and height, it's gonna just save it like this, a cropped image. So we don't want it to be a cropped image. So width should be, let's say 900, height just say 400. Update preview, it's still bad. Let's say if come to 1200, it's better now, but it's maybe too far gone. So this is 1000. 1000 is kind of okayish. Let's say do 350. Hit preview, this better. And now we have to adjust the directory. I want to do the same directory as I actually am, where I'm doing the analysis, where I'm keeping all the analysis file. So this is the directory. What's the name of this plot? This is SRT eligibility. This is SRT eligibility. Now this is save as SRT eligibility plot, and let me show you. So this is the plot now that we have saved. Okay. Now,
Nice and clean.
I'm sorry. Yep, nice and clean. Yep. So the next thing is we can do funnel plots. So what I need to do is funnel. The same thing, meta SRT. Funnel, I don't have to do. So this is the funnel plot. Would tell me the funnel plot. Now, whenever we do a funnel plot, we always should be doing the bias testing. Funnel plot. The only point of doing a funnel plot is see if we have any missing studies in our analysis to check the bias. In order to check the bias, there are multiple tests that we do. So the test that we do is meta bias, meta SRT, in which meta analysis we're going to do, and then what method do you want to run the bias with. So the usual is method.bias, and the one of the methods in eggers we can do deeks, you can do eggers. I actually like the eggers method, and then you have to specify what's the minimal number of studies. Normally, whenever you are running bias testing, you should have at least 10 studies to run the bias. Here we are not having 10 studies. So I can technically, so it will not run the bias here. The analysis needs at least 3 studies, minimum 3 studies to run the bias. Let's say if I do k-min is equal to 1, and I try to run the bias, this says just one observation. Drop due to missing studies, and you have only 2 observations, you cannot run the bias. So, but if ever we'll come with a study which has at least 10 studies, we'll be easily able to run the bias setting. But I just want to tell you how to run the bias, and a way to check the coding of bias, do meta bias, and this is how you check the coding of bias. Meta bias X is the element, the method.bias, then k-min. This is how you do it. So this is our first meta-analysis that we have done, is a binary meta-analysis. Everybody clear on this? Any questions? Okay,
Just a
Hamza,
question, Hamza. Like, when you are like adding these commands, are you pressing enter or like
Alt
because
plus
I was
enter.
like
I'm selecting them and doing Alt and Alt plus enter.
alt plus enter. Oh, okay. Yeah, I was trying to do the
Yeah,
while you were doing it, but yeah, I was
yeah,
pressing enter, but it wasn't like reading the command or
yeah.
okay,
So you
that
can
makes
always
sense.
select them and do this run command, but I do Alt
Oh,
plus
okay,
enter.
run. Okay.
Run command, but I
And
do Alt plus enter.
And that allows you to run that particular code without having to
Yep.
go through the run pro. Okay,
Yep.
thank you.
So this is the particular code that is run. If I'm doing all this together, in R, I mean, I know when you do meta-analysis in Stata, what the way Yasir does, he runs the whole meta-analysis. He writes the whole full code, and then so he writes the code in blocks, and then once everything is clean, he runs the whole thing. Here I do code, run, code, run, code, run, and I extract the data as I'm going through.
And this allows you to test code before getting to the end and realizing there's a message somewhere. Okay.
Yep. Okay. Now this is the bias, meta bias. Sorry, meta bin, binary meta analysis. So take a look at the next outcome. So these are mean SD. So it's say mean SD, mean SD. So these are continuous outcomes. Mean SD, mean SD. All of them are continuous outcomes. So normally when I've asked you to write continuous outcomes, I want you to write n mean SD. Like what is the total number of patients on which these mean are done. So I'm assuming that this is the same number that is here. I'm assuming.
Yeah.
So it should not be a problem. But normally when we are running meta-analysis, that's why I would say 4 columns for a binary outcome, 6 columns for a continuous outcome. Events total for binary, n mean SD, n mean SD for continuous. Okay. Now the next continuous is VO2, the peak VO2. Okay. That's what we're saying.
I'm missing that. I'm saying for binary, you wanted 4 columns and continuous.
4 columns.
4 columns. Can you highlight what you're talking about?
Okay, what I'm saying that whenever you're collecting data for a binary outcome, I want events in experimental, total in experimental, events in experimental in a separate column, total in experimental in a separate column, events in control in a separate column, and total in control in a separate column. Because when we are uploading everything into the software, it wants everything in a neat separate column. That's why 4 columns for a binary meta-analysis.
Okay. And then for continuous, it's total that's added?
No, it's in continuous, we have mean and SD, right? Mean of some, for example, let's say you are comparing blood pressure of 2 groups.
Yeah.
Okay, there is one drug is, let's say, lisinopril, one drug is valsartan. So lisinopril is your experimental, valsartan is your control. So you get the blood pressures of all the patients in lisinopril and valsartan. And at the end, you have mean blood pressure in lisinopril is 25. And you also need SD because SD is the measure of spread. Right? Whenever you're comparing continuous outcomes, you need the central tendency. And you need the center, the spread, the measure of spread. So you need mean and SD.
Yeah, so I got the statistical part. It's the statistical part I got down. It's your formatting. So
yeah. So the formatting I want is you need 6 columns for continuous because the first column you should have total number of patients in experimental. Right?
All right.
Here, the total number of patients in experimental, there is no column separate for that. But
okay.
I am assuming that the total number of experimental patients are the same as srt.n.meva.
Okay.
Okay. And the second column should be the mean of what you are finding out. So we are checking peak VO2, mean in MEVA. Then peak VO2 in SD in MEVA. Then the 4th column should be total number of patients in the control group. I'm assuming the total number of patients in the control group are srt.n.placebo.
Yep.
Then VO2.mean.placebo, 5th column. VO2.SD.placebo, 6th column. So that's what I want. 4 columns for binary, 6 columns for continuous. Does that make sense now, Ryan?
No, it would be helpful if you could just tell me like one by one. Don't use the case example. Just give me the generalization. For the first column of continuous, you want what?
Let me give you the generalization. Okay. So let's say you have a continuous outcome blood pressure.
Yeah.
Blood pressure. Okay. So we said BP, and we say we have N of lisinopril.
Yeah.
Then we need mean blood pressure in lisinopril.
Okay.
Then we need standard deviation of blood pressure in lisinopril.
Okay.
Then I need total number of patients in Valsartan, because
Okay.
now this is the control group.
Got it. So what you're really looking for is total mean standard deviation. Total mean standard deviation for each
Exactly.
experimental group. Okay,
That's what I'm trying to say.
Three for each experimental group. Got it.
Yeah, 3 for each experimental group. 3 for experimental, 3 for control. That's
Yes,
what I
sir.
want.
Got
And
it.
the reason I'm telling you is this. The reason I'm telling you is because let's say I'm just now trying to do the meta count. I'm gonna do the meta bin. Initially, I did the meta bin. Now I'm do the meta count. This is a continuous variable. So meta count, you see n.e, mean.e, st.e. That n.c, mean.c, st.c. So that's why 6 columns for continuous and 4 columns for binary.
Got it.
So now the next thing in our list is peak VO2. So I'm gonna say meta peak VO2 signing, then meta count, then n dot e is the total number of patients in the event, which I assume is the same as this variable, srt dot n dot meva. Okay, total number of patients in the meva group. So I'm gonna say srt dot n dot meva. Then mean in experimental group, which is VO2 dot mean dot meva. You guys agree? You guys agree,
Yep.
guys?
Yeah.
I'm taking notes, so I'm just a little behind, but I'm sure it's logically sound.
Yeah, I'm just saying right now we are just assigning variables.
Yes. Okay.
So n dot e, total number of patients in the experimental group. Where in this is the total number of patients in the experimental group? Where?
You have N. I see an N right there. I don't know which one you're doing right now.
This is the total. So this is the total number of patients in the experimental group, right?
Yes.
So I just put it there.
Yes.
N dot e,
Yes.
right? Then mean dot e. What is the mean of the total number of patients in the experimental group? So right now we are checking the mean VO2. So this is the mean VO2 in the MEVA.
Yes.
Okay. Then I'm going to write SD dot E. What is the standard deviation of patients in the experimental group? So the way I named it, I do VO2 dot SD dot MEVA, which is VO2 dot SD dot MEVA. So I first announced here the number, then mean, then SD of peak
Yes.
VO2.
So now your nomenclature makes sense. Thank you.
Okay. So now N dot C is what? Total number of patients in the control group,
Yeah.
which is the same as this one, right? SRT dot N dot placebo, N dot C.
Yes.
Okay. Then mean dot E, mean dot C is VO2 dot M dot placebo. Okay. I'm just gonna copy this here. I'm gonna say VO2 dot M dot placebo. Then SD dot C is VO2 dot SD dot placebo. You guys agree with this?
Yeah.
Okay.
Yes.
Yes.
Mubashir, can you hear? You haven't
Yes.
spoken a word.
No, I am just concentrating.
Okay. Now the next column is stud lab, study label. What's the study label? What's the study label in this one?
It is. Well, you have Millen. Oh,
Study.
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 Yeah.
Okay, the same as this one.
Mm-hmm.
So just gonna say study. Then what is the data?
Meva.
It's this.
Data is MEVA, right?
Thank you.
Mm-hmm.
Then what is I have no subset. So if you want to do subgroup, you can do subgroup, but I don't care about subgroup, exclude cluster. Sometimes you can do median, but I usually have this data in a single way, in either means or median, but I prefer in means. Method dot mean. What method are you gonna do with mean?
It says you said like you like MH, but it says LUC.
HG.
So that's for binary.
HG.
So I do just Leo. I
Leo.
just use Leo. Actually, this I can
This is
actually
for
delete because this is just to convert medians into means. So we just delete this. I don't want them. Just forget
okay.
about this. So the next thing is summary measure. So summary measures, let's go to summary measure. So what are the summary measures do we have? Summary measure is mean difference, standard mean difference, or I don't know what ROM is, but what I usually use is I use standard mean difference, standardized mean difference.
SMD.
SMD. So so mean difference is just a difference of means. Standardized mean difference it controls them. It adjusts the mean difference based on the number of patients you have. So if you have high number of patients, and one group has a low number of patients, it adjusts their mean difference so they are more or less comparable. So I use standardized mean difference. Then standardized mean difference, that method.smd. What method you already do for SMD? So there are two methods for SMD most commonly that are used. So one is Cohen's D and one is Hedges D. So I mostly use Hedges, but some people prefer Cohen's as well. So I'm gonna use Hedges. Okay. Then one thing is another method that I want to tell you is so initially method.mean, there is one more variable that I need to put it in, which is what exactly what is the method. Normally when we do continuous outcome, we do inverse variance method. So I'm going to see where in this is the inverse variance. The summary measure, what is the inverse? So this is the method.smd. Normally the inverse variance.
Can you type it in the search bar? Like there's the
Yeah, I
search,
think
would it
so.
show up? No, it wouldn't show up.
It's went actually somewhere else. But on the as a what I'm sure as a standard, it always run this as an inverse variant unless you unless you do something else, unless you give it another command. But if it's inverse variance, I'm just gonna do it like this. Then the next thing is random or fixed. So random is true. So let's see if it runs. So it says studies with get no. So it has run the meta-analysis, but it says studies with non-positive values with NE or NC get no weight. So I think there is a study in NE or NC which is a non-positive value.
Right there, the placebo.
No. This is the study that has no.
As in
So
not
here's the
applicable.
thing. Here's the thing.
That's why you don't prefer NA.
Yeah, that's why I do not. So the other thing is which we do not have is what is the number here? What is the number here? Because it won't run these values until you have srt.end or srt.neva. So can you check the numbers right now?
Let me look it up.
And let me know. I will update the data.
Is there a way around that, Hamza, if you just don't have, if you have missing data
No.
there?
So we need these 6 values for all the studies. If any study has missing n, so here's the thing, right? You if you think about it logically, you are comparing two different means, and the means are 220, 2 plus 1 plus minus 1 and 3 plus minus 1. But you don't know the number of patients you are comparing them in.
Yeah, you can't do that.
Exactly, you cannot do that. So you need the number of patients. So here the problem is we do not have the number of patients in this variable.
Maybe the numbers are like if you go ahead to the right, they may be numbers.
So the numbers are not in the original file.
But here.
So here there are no 6 columns. There are 4 columns. That is one thing in the data. That's why I say 6 columns for everything. You see what I'm saying? So
yeah, got it.
So if you do not have the numbers here, it's always gonna exclude this study. It's always gonna exclude this study.
So you would need. So if you were to delete.
Let me tell you what's happening. So this is exactly what's happening.
I know that's why you say you want 6 fields or 4.
Exactly.
4 fields. I know, but what I'm saying is if you delete study 3 and run it, would it run? But you said you needed 3 studies,
So
right?
so here's the thing, right? If I delete study 3, let's say I delete this study.
Yeah, there is no comparison. Like
There
there
is
is
no
no other
comparison.
study.
You need at least 3.
I need at least 2 studies. So here there is only 1 study for this one.
Mm.
For this, there is only 1 study.
So you would lose another computation down the road.
Exactly. I can run analysis for this one. This has all 3.
No, it has two.
So this is all 3, but if I delete this one, at least it has 2 to run analysis on.
I
Hamza,
got
I
it.
got the numbers just
Okay.
in case if you wanna like
Yeah.
in the Meva group. I think that's a comparison. Like this study had like 2 Meva groups, group 1 and group 2, different doses.
Mhm.
So if I can, do you want me to combine the number for the 2
So
groups?
here's the thing. These numbers are based on what? Single Meva group or 2 Meva groups?
These numbers are based on the 2 Meva groups. Like one was getting 200 nanogram per ml. The
You
other group
combined
was
them?
getting,
You
yeah,
combined them?
let me
When you were
check.
collecting the data, did you combine them?
Okay, 40. Meva group had like 40 and placebo had 19.
Okay. So if you want, I can put it in analysis and run the analysis. That would be okay.
Yeah,
Okay.
and I can update the data sheet as well.
Okay. So I am actually updating this. So now, because we changed the data, I have to load the data here again.
Oh,
So I loaded the
Yep.
data here again.
You have to redefine the variable again?
I have to load the data again because I changed the data.
the data
But
sheet.
it's not going to be difficult. So I just use this command. After I use this command, the same thing. It has the same variable. I don't change anything. This is the dialog box opening. I saved it in this one. I opened this one. So now this is the Meva. So now it is 40 and 19. You see what I
Got
did here?
So I can be sure, can you go back to the line you used to reload it?
Okay. So
What the
this
prompt
is,
was?
yeah, I'll show you again. So this is the data file, right?
Yeah.
This is the data file. This data file, Hamza just told me that the total number of patients in the Meva group is 40. Total
Yep.
number of patients in the placebo is 19. So I just added 40 and 19 here.
Yep.
Simple. I saved it. It's not saved.
Yep.
Okay. Now I take it away. Now this is the R file, right? I
Mhm.
need to reload the data in the same variable. So I just run this command again.
Hmm.
I run this command, all plus enter. This is the dialog box that opened, right?
Yep. I think I got it now.
So this is the dialog box that opened. This is the same file that I just saved, right? I opened it. So now the data is in this file. Okay. I say view Meva. Now I have 40 and 19 here. Simple.
Got it.
Cool.
It won't go ahead. Ryan,
I was just saying cool. Thank you.
cool. Okay. Now I have the values here. Now let me run this again. I don't need to do anything for this because for this one, there was already nothing here. So that doesn't matter. I can probably run this again. It won't change the results that much. So I would just run the previous one here again. It just add 40 and 19 here, but this is
Mhm.
still negative. So I can just, just save it as srt dot eligibility. This one we had 350 and this one we had 1000. Update preview and then save. I just saved it previously. I just overwrote it. And now if I go to this one, so this one now has 40 and 19 in there. So this is done. But
Just a random question. Like, for
yeah,
example, we run the analysis completely, and after that, we find another study
yep.
that we have to add. So
Mhm.
the code we created, can we just save it as
Yep.
a
So you can you can add the file, you can add the study to your initial analysis file as a new row
Mhm.
and use the same code, run the codes again, and you're done.
Got it. Okay.
Okay.
Like we can save all this
Yeah, we
coding
can save
as a
all this.
file.
I will share
Got it.
with you.
Got it.
So I am just, so this is the meta-analysis done, and this is in meta peak VO2. Okay. So I'm just writing meta peak VO2. And this is inverse variance method, Hedges D, bias corrected standardized mean difference. That's what I use, Hedges D. And this has total two number of studies. And I'm gonna save it in a EndNote in a notepad file. Actually, it's not SRT eligibility anymore. It's untitled. It's peak VO2. Okay. Then I saved it. It has everything in there. Test of heterogeneity is, I think test of heterogeneity is still negative in there. I can show you here. So save where, peak VO2, save in the same folder, close it. Now this is the image. I just need to adjust this image a little bit and go to 1000. This will probably need some more space. I think it's same. Okay, this is actually, I did the wrong thing because I need to run this. Okay, meta peak VO2. Okay, label E.C. Now tell me, peak VO2. Let me run this. So this is the new forest plot. Okay, now peak VO2 value is, so peak VO2 is more in placebo and less in mavacamten. So peak VO2 is a good variable and a bad variable. That you have to decide. So that's when
I mean,
you
it
read
looks,
the,
by the look of it, it looks like a bad variable for mavacamten study, like
but
mava patients on
so
mava.
if you have peak VO2, then I think it's a good variable. If you have increased peak
Yeah,
VO2, then you can do more exercise,
yeah,
right?
but
Yes.
Peak
for our
VO2
meta,
consumption. But I'm not saying that it's our meta says
Mhm.
that peak VO2 is more in placebo, but it is
Mhm.
non-significant. That's
Oh,
what our
okay.
meta is saying.
Oh,
Okay.
okay.
So you have to go to the study, go back to the study to see what peak VO2 means. Is it more in placebo or more in mavacamten? And that's what you have to make that distinction.
Okay.
Okay. So I'm going to give you the images and everything, but what I wanted to do is after we are done, I wanted to go back to the studies, read these variables and see what is the significance of these variables. And you may have to
Okay.
run the analysis changing the favors placebo, favors mavacamten, and I want you to make an abstract for that.
Okay.
Next, Peter, I don't know if this helps, guys, but I actually have the ACC summary pulled up. It seems the peak VO2 is greater in the placebo group than mavacamten.
Yeah. So this is what it's saying, right? This is what our
Yeah, our
meta-analysis is saying.
meta-analysis is
Yes,
saying the
Saying
same
the
thing,
same thing.
but
Yes.
I'll definitely confirm after going
Is
back
it,
to
so
the
the
study.
thing is it a good variable or a bad variable? That's the thing. If it's a
It's a
good
good
variable,
variable.
and if it's a good variable, it is more in placebo, then it means that our drug is not doing that well. If it's a bad variable and more in placebo, then it means our drug is doing well. That's how we decide. So save as image, and the image is being saved as peak VO2. Height we just 375. Width I think is going to be 1200 this time. Maybe just 1100. Yeah, this is good. Now we save it, and now it's saved. Where is it saved? It's saved here, and this is the peak VO2. Clean.
Got it.
Okay.
But
Now,
for example, if it was a bad variable, then what?
if it's a bad variable, then we'll have to. So if it's a bad variable,
You would flip the left and right, right?
you will have to switch the left and right exactly.
Oh,
Got it.
Okay. So let me show you another way. Mortality is a good or bad variable?
Bad.
Well, dying
bad
is not a
variable.
good variable.
Exactly. Dying is never a good variable.
Yeah, I mean,
So mortality is a bad variable, right? So if you have an increased mortality, let's say on this side, let's say we have increased mortality on this side, and our drug has actually low RR for mortality. Then we're gonna say on this side favors mavacamten, this side favors placebo. I will show you another way. If we show the
Got it.
previous meta-analysis, I'll show you another way. Then we'll have to switch the left and rights. That we have to take care of. Okay. Now we are done with the peak VO2. We are done with the binary variant. Now the rest is very easy. So let me show you the rest. So all these are.
Just another question.
Yep.
Can we go back to the untitled?
Yep.
So in the meta bin, in the SM, in the meta bin, in the SM we did RR.
Yep.
So it is like all these were the trials, right?
These were the trials, yes.
But if it was like there were like 10 observational and 10 trials, then
So
like
I can run OR on trials as well.
got it.
I can run
Because
any of, so I can run OR and it would just, so this is RR, right? So this is peak. Let me just show you this. Let me do this meta SRT2, just adjusting this and
Mhm.
just keep it as RR. I don't want to mess the variables. That's the reason. Okay. Everything same. I'm just doing RR to OR. Run it.
Mhm.
I have a meta SRT2. So let's do meta SRT. Okay, this is the meta SRT. 0 point between 0.2 and 0.5. Let's say I do this meta SRT2. It's for the
Mhm.
less. OR is for the less. So it
Got it.
so I just changed from OR to RR. So that's what I did.
Got it. Got it.
Okay.
Thanks.
So okay, now what I was trying to say is that we rest of the variables, NIHA improvement, this is NIHA improvement, KCCQ, EF,
Mhm.
and LV filling pressure. They're all continuous variables, right?
We-
So
So
metas can't.
Yeah, we just need to change the first
I
three
just need to,
alphabets. So
instead of VO2, I would just say, I can do this, R, sorry, uh, or F, fine, VO2, and replace it with NIHA. This is control plus replace all.
Mhm.
Replace, 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 all are replaced. So now I just run this, same thing. Now I have meta NIHA, and I have meta
nice.
NIHA here. So
Nice.
this is,
So all you're doing is you're taking in the variables from your spreadsheet and making new variables in R and then running the code you
yep.
had from the past.
So the
Okay.
way I make my variables in the spreadsheet, it helps me to run the analysis smoothly after that. I have to
Yeah, yeah.
just make a template and I just run variables. After that, I just did very quickly. So this is NIHA improvement. Okay, NIHA
Mhm.
improvement, and then I just save it. Save it where? Save it here. It's already saved. Now I have to make a forest plot. So NIHA improvement is a good variable. So
Mhm.
so here's the thing. Now there's a trick coming up.
Mhm.
Actually, I made a mistake in the past. I made a mistake.
Oh, meta
Meta
peak Naya.
peak VO2. Let me tell you. The reason I'm telling you I made a mistake, because here's the thing. This outcome is this minus this.
Mhm.
This minus this. So if it's positive, then it means this is high and this is low,
Mhm.
right?
If it's negative.
If it's positive, means these are all positive, right? 0.37,
Yeah.
0.24. So it means this is high and this is low.
Mhm.
It means that this side is favoring Meva-Cam
Meva
correlation.
as compared to placebo. We just need to change the. Do we need to
So
change it on the
yep, now we did
first
change it.
one? Oh yeah, that's a good deduction.
Yeah. So that's something I made a mistake. So now let's correct this mistake right here. So we corrected the mistake because peak VO2 is high in Mevacamp, and that's why it's positive. We save is, we say peak VO2.
I think the true
But this
variables
is the
need
and
to change in peak VO2, not peak VO2. But
Yeah,
anyway,
it's
that's just
no,
we're just splitting hairs.
so no, it's we're not. So let me just say. So what we are doing is it's a standard mean difference. It's peak
isn't
VO2 in experimental minus peak VO2 in control, and then you get the result. Okay, Ryan, let me
I, I,
let
I
me
go ahead. But what I'm thinking, I'm not so much responding to the variables you chose. I think that the true variable that is in the studies you guys referenced is change in VO2, but
Mhm.
I don't know if it really matters.
Yeah. So this is what I'm just trying to say, that what mistake I did was, it's actually not so in binary variable. So you have to pay attention to this thing. What is RR? In bad outcome, the lower the RR, the good you are. In
Yep.
good outcomes, the higher the RR, the good you are.
Yes. So you have to flip the labels in
We have to
the
flip the
graph.
labels.
Yeah.
But here, the positive, the more positive the SMD means, mavacamten is high and placebo is low, and it makes sense, right? So 1.4, 3.1, and minus 0.1 and 3. So 1.4 is higher than 0.1. That's why it's positive.
Yes.
Okay, it means that peak VO2 is higher in mavacamten than placebo. So it should favors mavacamten.
Yep.
That's the
Yep.
mistake that we initially did, which I corrected now.
Now
Got
it
it.
makes sense.
Okay. Peak VO2 1100, 375. What's happening? Yeah, overrated. So overrated. Now it's done. Now peak NIHA. This is peak NIHA. We already did that. Actually, it should be just NIHA, but because we
Mhm.
just so the same thing here. The better the
Mhm.
the more the NIHA is mavacamten, so it supports mavacamten. So our
Mhm.
study is overall favoring mavacamten overall.
That's true.
NIHA change. Let's do 1100.
Hamza, just a random question. Like most of the outcomes that or the analysis we do for the meta, are those variable has to be like binary and just continuous, or there has been like any other variables that you had to do a
What
different
other
meta?
variables are there? There are four types of variables. There are binary, continuous, ordinal. Ordinal has three different types, but most of the
Okay.
variables, the outcomes, are in two variables. And we try to, if there are three variables, let's say three variables are there when you have three different classes.
Mm-hmm.
Okay, then
Okay.
if you have three or four, so these comparisons are for two different things, like mavacamten placebo, A versus B, C versus D.
Mm-hmm.
But if you have A versus B versus C versus D, then you do a higher level of meta-analysis, which is a network meta-analysis. Okay,
Oh,
I
okay.
want you guys to learn this coding first and
Mm.
be proficient with this before we go, because that is a new package. That's completely different thing.
Mm-hmm.
Okay,
Okay.
so NIHA change, we saved this. This is done. So now we're done with three of our meta-analysis. Now we
Gotcha.
say KCCQ. Okay,
Mm.
so the same thing.
Same
We have to
thing.
change NIHA to
KCCQ.
KCCQ and replace. We're done with replacements. So we just do this. We're done
Right.
with the KCC. This is the KCCQ notepad. Okay, two values, file, save. Now tell me, is higher number in KCCQ is a good thing or bad thing? That you have to tell me.
It's a good thing because that means more accessibility
Accessibility. Okay, then you see Mavacamten is favored because Mavacamten is high. But here's the thing that I was talking
is
to you
going
about,
out.
the limit, because it's going beyond. Then I have
Mm-hmm.
to adjust the X-limbs, the limitation on the C side. It's, I would say, -1 to +1. I think that's the best one. Now it's better. Looks better.
Yeah, pretty.
Okay. Now we just export it as KCCQ, adjust it as 1100 and 350. Update view. It's all in the good shape. Save it. Saved. Everything is being saved here. So now we have KCCQ and I have changed peak view to SRT eligibility. Now what else do we have left? So we have KCCQ and now we have
Yeah.
EF. Okay. EF. Now we just have to do this KCCQ. Then here we just do EF. Then replace. Everything is replaced. Meta peak EF. That's EF. I just do the meta analysis here. So EF, So EF, I think EF is not a good one. EF
Mm.
is,
Yeah, based on the literature, EF does not favor mavacamten. It's actually decreasing.
yep. So we have to do this. Mavacamten. So, oh, actually, sorry. This does not favor
Yeah.
mavacamten. No, this does not favor mavacamten. This
Mhm.
actually
So it's placebo.
favors placebo. So this was the right from the beginning. So this is
Mhm.
something we have to say that mavacamten is actually not good for EF.
Mhm.
Yes.
Now we save it. Now what's the last thing we have is LV filling pressure. I just wrote LV
Mhm.
fill. EF. Let's see LV fill. Place. Okay. Same thing here. Oh, I'm actually sorry.
Oh.
Meta peak KCCQ. Did I write KCC? I think I wrote KCC, but I did not write EF. I have to make text files of these ones as well, right?
Mhm.
Uh, so KCCQ, now I have peak SRT EF. Now I have EF. Now I have LV fill. Let's copy the LV fill thing. Done. Now I just have to do the
Forest plot.
forest plot, and this is the LV filling pressure. LV filling pressure. Why is not placebo not written here? That's curious. Oh, because label dot
Oh.
left was adjusted. Okay, because it was EF, right? So I was
Mhm.
collecting all the EFs. It collected E
Yeah.
left as well. So now it should be here. So LV
That
filling
seems
pressures. LV filling pressures are um more
worse.
in mem.
These are all in minus.
Yeah, so
So
LV filling pressures are what I should say are less in mavacamten than in placebo.
Yes.
yeah, and that's a good thing.
That's a good
So
thing.
mavacamten.
Okay. So here's the thing. We are done with so LV filling
Well,
pressures.
Oh, you guys are doing filling pressures. I'm so out of it, guys. I thought you were still on
Yeah.
injection pressure.
So now we have any variable left. I'm trying to see. So let's see. So we did VO2, we did NIHA, we did KCCQ, we did EF, we did LV filling. We're done with our meta-analysis. We're done with our analysis. The last thing I want to tell you guys is I was telling you about the meta bias, right? So meta
Mhm.
bias, ideally you should do when you have 10 studies. So in this study, you have only 3. You should not run a meta bias testing. But
Mhm.
I'm just going to tell you, if you do run it, how does it look? So normally you came in should be 10. But in this case, let me see which study has at least 3 variables. Three which way outcome is reported by at least 3 studies.
I think
The
EF.
only outcome which is reported by all 3 studies is NIHA.
Now, yeah.
Okay. So I can only done it on NIHA. So meta, peak,
And
NIHA, okay, Eggers and Cayman is 1. So if I do, let's say funnel, meta, peak, NIHA, how does it look? It's going to show you guys. This we should not do it. I'm just telling you how does it look.
Mhm.
So this is the 3 studies. Okay. If we do a meta bias testing, so this is the Eggers test. Okay. So this is the
Right.
p-value of the Eggers test, which tells you that it's non-significant. It means there is no meta bias in there.
Okay.
But because there are only 3 studies, you should not do it. I'm just
Mm.
telling you how does it look like. So this is our analysis. So once I'm done with it, I just go save it. I just save it in the same folder. So this is the same folder. Okay, not this thing. Save. Save as, remember Campton, R analysis file, not CSV, R analysis file, save. So now it's saved. Now, if I even close it, just don't save it in the R trajectory. So there should be an R analysis. So this is the R analysis file. I said always open with RStudio. So it will open up the same file, an R analysis file. So this is opened up.
Oh, that's how you used to save the code.
Yeah, that's how I save the code. Code is saved now. Now I'm gonna share this with you on a Google Drive so that the drive. I'm just gonna say new. I
I'll put in
want
a
you to.
drive link on the Meva Campton group though, like if you want to.
I don't have
So,
access to that, Mava Campton.
oh really? Think-
Yeah.
Okay.
Or I'm just gonna create it, and I want you to fuse those two folders together. Can you do that?
Yeah, I can.
Yeah. So let me just here. Yes.
Just a random question.
Yeah.
So when we are when we are making a supplementary file and we are combining these images together, is there
Yeah.
like how you do it?
So that's the worst part of the meta-analysis that I have to do. So what I have to do is I have to make a collage of these in Paint. So
Mhm.
let me show you how to do it. So let me open a Paint. This is the most cumbersome part that I actually have to do.
You need Photoshop, sir. That's what you need.
I need that. I don't know. I
You
don't know
can
how to
Adobe
work with
Photoshop.
Photoshop, but I really need that software because this is what I do. So take a look at this. So EF, I copy it, minimize it. I open up my Paint, and I just select eraser on it, and this is it. And then I have to manually write stuff on it. That's the
Um,
biggest bane. That's why I asked you guys to do. So if you guys know a better way, please let me know and please teach me, and I would really love to learn that.
Okay. And
What what
another,
what, what are you adding onto it? The title,
So I add
figures,
title
like
at the
figure
top,
legends.
and then what exactly is that outcome is, because the outcome is not shown here, right? The outcome is in the title, but the outcome is not here. So I actually write it here. What is the exact
yeah.
outcome?
Label it
I have to
probably.
label it.
and after like copy pasting like three
And one
pictures.
thing I think we made a mistake. So this is Meva Cam 10. This should be Meva Cam 10.
Yeah, yeah. The legend needs to be changed.
Yeah,
But yeah, Photoshop would be ideal. But
yeah,
that would require lessons. If I can find a way around it for you, I'll let you know.
yeah. So here's the thing. Um, Hamza, because you are dealing with the study, can you change?
Mhm.
So you have to just run this R file on your system, whatever, however you want to do. And can you
Okay.
change this? The other way to do around this is this. So you can actually edit that in Paint as well if you want.
I'll do the analysis. It would give me a good practice as well, just in case,
Okay.
because I think the paint idea seems cumbersome. Like I knew like because I tried to do it, but
Okay.
yeah, it was painful. Like I
So you
didn't
do the anal.
clarify everything.
Matching up the text is going to take you longer than finding out how to,
Yeah,
go.
exactly. Yeah. So thank you guys. Thank you for coming in. I hope
Well, thank
you.
you for
I
teaching us
Oh,
as
thank
well.
you.
Like
This is awesome. Yeah.